China is quietly building something that, 10 years ago, would have sounded like a YouTube thumbnail joke, a ground vehicle designed to cruise at around 1,000 kilometers an hour inside a giant tube. And in the last couple of years, that idea has stopped being just cool renders and hype words. It's turned into hardware on a test track, hitting speeds that make airline CEOs sit up and watch. The project's name is Timey Flight, China's ultra-high-speed maglev in a low-pressure tube. Its backers are already talking, not quietly, about turning the Wuhan-Beijing corridor into a roughly 1-hour city center to city center ride. From your door in Wuhan to your destination in Beijing, faster than flying and eventually cheaper to operate than a plane. While the US is still fighting over environmental reviews and lawsuits just to get classic 300-kilometer-per-hour high-speed rail built in California, Chinese engineers are pushing a train in a tube that's already broken past 600 kilometers per hour in tests, with 1,000 in their sights. So what is Flight, really? At its core, it's not one wild new invention. It's two mature ideas bolted together: magnetic levitation and vacuum systems. First, the maglev. As of now, most trains ride on steel wheels over steel rails. That's friction, noise, and heat. Where a maglev train floats instead, literally, on magnetic fields. No physical contact with the track. No rattling over joints. Just a pod hovering on a cushion of magnetism. China already has a commercial maglev line between Shanghai and Pudong Airport that does around 430 kilometers per hour in daily service. That's already faster than almost anything else on rails. Flight's twist is to put that floating train inside a sealed tube and suck out most of the air. Drop the air pressure, and you drop drag, and suddenly speeds that would be insane in open air start to look realistic. The numbers from the last couple of years are what turned this from sci-fi to, okay, this is real. In one widely reported test, a scaled flight vehicle, just a couple of meters long, ran in a low vacuum tube and hit about 623 kilometers per hour on a track only around 200 meters long. Other runs in a 2-kilometer test tube in Shanxi have shown full-size maglev vehicles moving stably at similar speeds. China's aerospace and rail research groups have now completed a full-size demonstration in Datong, Shanxi, of a maglev system built for up to 1,000 kilometers per hour in a low vacuum tube. They're already talking about a second testing phase, extending the tube to tens of kilometers and letting the train stretch its legs toward that 4-digit speed. To be clear, there's no paying passenger service at 1,000 kilometers per hour yet. What they've proven is a working, full-scale system in test conditions that can pass 600 plus and is designed on paper to hit 1,000. But if you zoom out from the test track and look at what they're aiming at, the picture gets a lot bigger. Chinese media and planners keep coming back to the same example. Wuhan to Beijing. Right now, if you take a regular high-speed train, that trip is hours of ride time. A flight is shorter in the air, but you know how that goes. Getting to the airport, check-in, security, boarding, taxiing, delays, baggage. Your quick flight quietly balloons into a half-day. Thoughts designers say that if they can build a full corridor and run at around 1,000 kilometers per hour in the tube, that core ride time could drop to roughly half an hour. Fold in local transport on both ends, and you're talking about something like an hour door-to-door, with stations plugged directly into existing city transit instead of remote airports. In other words, it takes a trip we currently treat like intercity and makes it feel psychologically closer to crosstown. The threat to aviation makes more sense once you look at the economics. Planes are amazing, but they're wasteful for short hops. They burn tons of kerosene to stay in the air and push through thick atmosphere. They need long runways, big airports, air traffic control, weather buffers, and you pay for all of that in ticket prices and time. A Maglev capsule in a low-pressure tube is the opposite. There's almost no drag once you're up to speed, because there's barely any air to push aside. Most of the energy goes into accelerating and a small trickle into keeping the capsule coasting. The vehicle runs on electricity. Once you paid for the concrete, the tube, the magnets, and the stations, your routine costs are power, maintenance, and staff. China's conventional high-speed rail has already shown how this plays out. On many routes, tickets are cheaper than or comparable to flights, even though the lines were insanely expensive to build, because each train can move huge numbers of people at relatively low marginal cost. If flight ends up with a similar cost structure, rail economics on the ground, jet-like times in the tube, then on dense routes under about 2,000 kilometers, it starts to look like a faster and cheaper choice than flying. That's when short-haul aviation stops being the default and starts looking like the legacy option. For passengers, the ride they're promising looks less like an airport experience and more like stepping into a sci-fi metro. Picture this. You walk into a T-flight station in downtown Wuhan. No parking shuttles, no 40-minute taxi to the airport. You tap a ticket the same way you would for a regular high-speed train. You walk down to a sleek, sealed capsule. No giant turbofan engines, no wings, no clouds outside the window. In fact, maybe no windows at all, just screens. When the doors close, there's no roar, just a smooth push as magnetic forces take over and the capsule starts to slide forward. Because it's maglev, there's no wheel noise, no click-clack. As the tube pressure drops and you accelerate, there's no turbulence, no seatbelt sign pinging with every bump of air. From the inside, it feels like a very fast, very quiet subway. 10, 20, 30 minutes later, depending on the final speed en route, you ease back down to normal speed, dock beneath a station in central Beijing, and walk out into the city. No one ever asked you to take your shoes off. The ground never left you. But your mental map of far away just got wrecked. That's the surface. Underneath, this thing is a nightmare of engineering challenges, and that's the part Chinese teams are chewing through in the background. Maintaining a low-pressure or near-vacuum environment over tens or hundreds of kilometers isn't just about turning on a big pump. Tubes expand and contract with temperature. Ground shifts. Bridges flex. You have to break the system into segments, manage valves and seals, plan where you can safely stop and evacuate people, and figure out what happens if a capsule needs to brake hard at 800 or 1,000 kilometers an hour. That's why flight is moving in small, controlled steps. First, short tubes, modest speeds, no passengers. Then longer tubes, higher speeds, more complex control systems. Each record-breaking run at 600 plus isn't just a flex. It's a data point on how the vacuum holds, how the levitation behaves, how the braking system and emergency protocols work under stress. China has a big advantage that most countries don't. It's already an absolute monster in rail and infrastructure. It runs the largest high-speed rail network on Earth, with thousands of kilometers of track and a ton of experience running trains at 300 to 350 kilometers reliably every day. It already operates a commercial maglev in Shanghai. It has state-owned giants that pour tunnels, build viaducts, and throw bridges across entire valleys as a matter of routine. For flight, that means the team isn't inventing everything from zero. The idea of connecting big cities by rail is old hat. The idea of running complicated, high-speed systems nationally is baked into the system.